Hello, I'm Matt and welcome to this build log of my Silent PC Mark II, officially named Cloud Unit. Now if you've not seen this yet, I have done an extensive overview video where I explain the various features and sort of show you why this case is extremely unique. And one of the reasons is that the graphics card has a massive CPU cooler mounted to it rather than a standard graphics card cooler. And this allows the computer to be extremely quiet, even when playing intensive games. So do take a look at that video if you want to find out more. You can watch it by either clicking the screen right now or by following the link in this video's description. So, on with the build log, and if at any point you find it interesting, don't forget to give it a thumbs up. As the design of the case was defined by the CPU cooler being mounted to the graphics card, I first needed to do some testing to make sure that this idea would actually work. So that was really the first thing I thought I'd tackle. So mounting the cooler actually turned out to be quite easy. The first step was to remove the graphics card's original cooler and wipe off the heat paste that was on the chip. I then screwed 4 hex spacers into the holes already present on the PCB. After adding some new heat paste, it was then just a case of placing the new cooler on top and screwing a crude but functional custom bracket onto the hex spacers. I then did some burn-in tests and found that the temperatures were very impressive and that the fans barely needed to spin in order to keep temperatures more than acceptable. All this was despite the card's high power consumption of 187 watts, which is roughly equivalent to a current generation Nvidia GTX 980. Now, although at this point neither the RAM nor voltage regulators had any coolers on them, I did add them later. So now that I knew the idea had potential, it was time to start building the case. Unlike my previous case, the main material used to make it was aluminium. Part of the reason why this was chosen was because of its sound properties, but I'll go into that in more detail later. Now, as this was my first metalworking project, you'll have to excuse some of my techniques, as I was essentially learning as I went along. So, I went ahead and bought some right-angle aluminium rods for the supports, a large sheet of aluminium for the main structure, and also some smaller sheets of aluminium for any additional panels. So the first thing I did was cut the bottom vents out of the main aluminium sheet using a jigsaw, carefully following a line I had drawn with a knife. I then used some sandpaper to gently smooth the cut, removing any sharp edges. This was something I did throughout the build on all cuts and holes, as I wanted to not only make it safer for my fingers, but to also keep stray aluminium particles under control so that they wouldn't cause any problems when the components went in later. Next up was the motherboard tray. It was while making this that I realised that aluminium is actually a pretty fun material to work with, as it's soft enough to cut through easily, and it's possible to, for example, round off edges in only a few minutes using a file. It's very cool stuff, so expect more projects using it in the future. By the way, do you recognise this motherboard from somewhere? Yep, it's the one whose bent pins I fixed a while ago, so it came in pretty useful. So, back to the motherboard tray, which I then positioned on the main aluminium sheet where I wanted it, and carefully marked and drilled some holes for it so that the two could be screwed together later. Next I cut down some lengths of aluminium right angles and screwed them to the main sheet, forming supports for the additional yet-to-be-made panels. They were attached at this stage so that it would be easy to thread the holes, but most of them were removed again for the next step, which was to bend the aluminium to make that lovely curved front. Lacking any special tools for this, I ended up forcing it around a piece of PVC pipe, with the help of some wood, clamps and, of course, my dad. This was a little difficult, but the result was surprisingly good. The shape was further refined by gluing in wooden supports, which helped to tighten up the curves and added a lot of strength. At this point, a wooden base was also added, which was screwed to the bottom using some of those right angle edges I cut earlier. The supports and base immediately made the structure extremely solid, which was to be expected I guess, but it was still pleasing to observe. Next I cut out the access panel. Had it been cut out before bending the aluminium, it would have made it impossible to get a good even curve, which is why it was left until afterwards. I then made the additional panels for the case, using the jigsaw to cut out the various holes and slots. Now, as the GPU now had a heavy CPU cooler mounted to it, I needed a way to support it so that its weight wouldn't bend the card's PCB when it was mounted in the computer. To do this, I removed the cooler's top fin and glued it to one of the additional panels. This meant that when the card was fitted into the case, the cooler's heat pipes simply slotted into the holes on this top fin, giving the card the support it needed. This also meant that if I wanted to upgrade the card in the future, I could simply pry off the old fin and reposition it to fit with the new graphics card. So after a good wash to get rid of any leftover aluminium particles, these panels were then screwed to the case, using the right angle edges I prepared earlier. It was quite fun fitting it all together at this stage, as the case really started to take shape, and it was quite rewarding. As you can see here, the side panel had some lips added to the edges, and this allowed it to easily slot into the side of the case. Now, after making sure that everything was screwed in tightly, I began to remove the protective film that was protecting the aluminium. After seeing how gorgeous it looked, I really wished I could have left it exposed like this, but unfortunately, because of the steps ahead, it was inevitably going to get heavily scratched, so it's something I'll have to look into for a future case instead. So as you can see, these screw ends stuck out of the sides. These had to be individually cut, filed, and then sanded down so that they became flush with the rest of the metal. This took quite a long time to do, and it was quite hard work, so I'll definitely try and find a more elegant solution for next time. So the next step was to work on the power light, which works in exactly the same way as the shard light project I made a while ago. So I got a piece of thick plexiglass and began cutting it to match the case's front curve using the jigsaw. Now, unfortunately, because of the speed of the jigsaw blade, it caused heat to build up by way of friction, which had the disastrous effect of melting the plexiglass as it went. I had to resort to using a coping saw instead, which was time consuming, but it did do the trick. Now, it looks a bit messy at this stage, but this was addressed later, as you'll soon see. I then cut out some of the inner edge to leave a space for the vertical loading optical drive, and also made a slot for the red LED which lights up when the backup button is pressed. This plexiglass was then securely glued to the top wooden support. I also made a small front facade to fill in the gap above the plexiglass. I later mounted some white LEDs behind this facade so that they'd illuminate the plexiglass below when the computer was on. Now, you may notice that the plexiglass is now extremely smooth. This was achieved by spending much elbow grease on sanding it down until it became flush with the metal, as it was intentionally cut slightly too large. It made for a good workout, let me tell you, but the result, I'm sure you'll agree, was well worth it. Now nearing completion, it was finally time to add the components. First to go in was the backup hard drive. It was mounted to two right angles with rubber vibration isolators. Next to go in was the I/O panel, followed by the motherboard and PSU. Next in was the GPU, which slotted into the support fin quite nicely. After the power cables were plugged in, the PSU's power socket was screwed to the rear panel, as were the USB sockets. Now that most of the components were in place, there are only a few jobs left, the first one being to make the top panel. Just like the base, I chose to make it out of MDF rather than aluminium so that it would have some thickness to it and wouldn't flex if pressed. I used a coping saw to cut out the various ports, finishing them off with a file to smooth off the edges. After the card reader was glued in place, the whole thing was painted white as an undercoat for the vinyl wrap, which was then carefully applied by heating it up with a hairdryer and then smoothing it down with a plastic card. I then used a knife to trim off the excess vinyl around the edges and various ports. After it was finished, the whole thing was screwed to the case. More vinyl was then added to the rest of the case and carefully trimmed down around the vents and edges. So essentially the case was finally completed. The last few jobs were to add some plastic barriers to direct the air through the heat sinks, and to make some sound absorption pads, which were made out of a towel. These not only help to absorb sound, but also provide a soft mount for the fans. A pocket was also made out of the same material for the 2.5-inch laptop drive to reside in. I chose a laptop drive as they're typically quieter than desktop drives, and speed wasn't really a priority as it was for file storage. An SSD was of course used for the OS and programs, which resides above the laptop drive. Now the reason the laptop drive is in a pocket is so that the vibrations it generates don't get transferred to the metal of the case, which would otherwise amplify the sound quite a lot. Even so, it's actually the noisiest component in the computer by quite a way, so when 1TB SSDs are cheaper, I'll definitely be upgrading it. The very last step was to remove the vinyl from the light, completing the build. Now, one thing I've not mentioned properly is the backup system. As you know, the computer has an additional backup hard drive mounted inside it. When the backup button on the top of the case is pressed, this hard drive is connected to the computer's power supply, and once it's detected by the system, the computer automatically backs up the data from the 2.5-inch data drive to it. This works really well, and because it's so easy, backups are done far more frequently, and the speed is very fast as the backup hard drive is hooked up using a normal SATA connection. For those of you who would like to make a similar system for your computers, I will be making a dedicated video about it at some point, so make sure you're subscribed so that you don't miss it. So, just how well does this design perform? Well, in my next video I'll be doing some extensive performance tests, showing you some sound comparisons and examples. Here's a little clip to whet your appetite.
And despite it running the benchmark, you can only just hear it despite me whispering. That's how quiet this is. It's literally inaudible to me in the room.
So as you can hopefully hear, the performance is phenomenal. There are much more tests in that video, including whether you can hear my heartbeat over the sound of the system. So do check it out if you're interested. You can find a link to it in the description or by clicking the link at the end of this video. So what makes the case so quiet? Well, it's a number of things really. For starters, as the airflow path is more efficient at getting rid of heat, the fans barely need to spin in order to cool down the components. In addition, because of the layout, only 2 fans are needed, reducing the noise still further. Now, as I mentioned earlier, I had chosen aluminium for the build because of its sound properties. In my previous case build, I used dense wood, thinking that it would help keep things quieter by keeping the fan noise inside the case. As it turned out, the wood actually made the fans louder. This is because the case ended up acting like a resonant chamber, like that of a loudspeaker, with the sound bouncing around inside until finally escaping through the fan holes. While it was still quiet, the noise it did actually generate was unpleasant and hollow sounding. In comparison, my new build is much improved in this regard. As the case is made out of thin aluminium, lower frequency sounds aren't boxed inside, eliminating the problem with resonance that prevailed last time. So I think that covers everything. If you have any questions, feel free to ask me in the comments section, and I'll do a follow-up video after the performance tests, answering any FAQs. So don't forget to subscribe if you like this project, and as always, I hope I see you next time. Thanks for watching.